Hey kids, my name is Paul.
I'm Sal.
And our project is called Fruit Juice. The pun being that electricity is sometimes referred to as juice.
Yeah.
Yes, please chuckle now.
Lemon batteries.
Yes, we're making lemon batteries today.
Love my space.
Yes, very nice. So, when you think of lemons, what's the first thing that you think of? Feel free to shout out your answer.
Lemonade.
Lemonade, okay. What about specifically the flavor of lemons?
Gross.
Gross. Looking for a word starts with an S?
Sour.
Sour. That's right, they're very sour. Do you know why lemons are sour? It's because you're eating acid. And that acid can be used to make a battery. Now, a battery, in general, very generally, is some acid and two different metals. One that will give up electrons and one that will take the electrons. Sal, do you want to go more into that while I continue making this battery here?
Yeah, later once we have it set up a little.
Later once we have it set up a little bit? Mm-hmm. Okay. So Sal's going to talk about that in a sec. In the meantime, what we're going to do here is we're not only going to make a cell out of just one of these. We're going to make a whole bunch of cells with two different types of metals. And those metals that we're going to use a penny, and we're going to use a little bit of foil. If I may reach here. Does anyone know what type of metal is on a penny?
Copper.
Copper. That's right, smart kid. And this foil? Aluminum or tin sometimes, but we're using aluminum foil. Yeah, tin foil is bad. So we're going to use those two. And in this case, the copper is going to give up the electrons, and the aluminum is going to take the electrons. And we're going to make a little simple circuit out of it.
Yeah, except that's backwards.
Except that is bad. My mistake. That's right, because the fucks. Okay, so I should probably get that down. Anyway, so what we're going to do is into each of these, we're going to insert one piece of copper, a penny, and one piece of aluminum. And then we're going to wire them all together, sort of like they're holding hands. And that's going to, all of the powers of the batteries are going to add to give it extra voltage.
So if you've heard of voltage, it's sort of like, if you can imagine electricity as like water through a pipe sort of, the voltage would be like the pressure. Mm-hmm. So if you take, in that analogy, a battery is like a pump. And if you wire them together, so you have like two in a row, then the voltage is add. So one lemon cell won't make a lot of voltage, but if we wire them all together, we should get enough to light, to make some light.
Right. Would you kids like to come up and start sticking metal into these lemon cells here? Okay. Come on up.
So we actually need to make.
Did you bring them?
Yeah, I thought I did. Yeah, I thought I did. They're in my pocket, but my hand is all lemon. So what you can do is take some aluminum and.
No, I'm just gonna keep checking spots.
Yeah,
go ahead and just throw a penny in each one of those. No, okay. And my pickpocketing skills are pretty fine.
It's not in there. That's fine. So try to make some aluminum contacts. What you want is a little spike that can sort of stick in there, and make sure the metals don't touch.
Yeah, go ahead and just tear off a little bit of aluminum. Yeah, that's really important, is to not let the two metals touch.
Make sure the penny and the aluminum foil don't touch. So what happens is
a little spike.
So electrons are negative, right?
Right in there. Oh.
So what happens is the acid takes electrons out of the copper, and so if you lose electrons, what happens? You're positive.
That's right. If you gain electrons, what happens? That's right. Good job.
So the acid takes electrons away from the copper, and the copper doesn't like to be positive.
Come back up. Yeah, one more.
So what happens is the aluminum will give electrons to the copper if you have a wire going between.
Right. Now.
So now, for example, what we can do is this is a multimeter, and you can measure voltage. So what I can do is test the voltage of one of these cells.
These are alligator clips, by the way. You use them to connect different components if you don't want to actually solder things.
You can grip them, and they go.
Right. Like pretty cute.
So
all right, so
you just squeeze them to open them.
Yep, squeeze them open. So we're going to test the voltage of just one of these, and then we're going to wire them all together to test all of them.
So we test it is you just clip one onto one.
You touch the red one onto the positive, and you touch the black one onto the negative, which in this case are the copper and the aluminum, respectively. Mm-hmm. And if you look at our little multimeter here,
it's about 2/3 of a volt.
Yep, about 2/3 of a volt. Let's test
so, for example, like a AAA battery is like 1.5.
Right.
So we're just going to add a bunch together. And
yep. So if we add a whole bunch of them together, Do you guys want to take care of that here? Everybody just grab an alligator clip.
Alright, so here's what you do. You wire, you want to leave...
Yeah,
so
we're
let's-
going to leave this open and this open. This is going to be the most positive and this is going to be the most negative.
Let's...
And then from there, we're going to wire every piece of aluminum to every piece of copper,
Yeah.
just like that, all the way down. There we go. And if the electrodes fall out, which they very well might, just make sure you push them back in. Get them nice and sturdy, because if the battery falls apart, it's going to be a bad battery.
Yeah, just thinking about that. Alright.
It's a very tasty experiment. A little bit sour.
You don't need any money.
Yeah, don't need any
Because you will die.
No, you won't. Really? No, it's fine. I'm talking about don't eat copper though. Pennies are very bad.
They're kind of dirty, yeah.
They're poisonous.
Also, they're poisonous. Why
Yes.
are they poisonous?
Because copper will kill you if you eat it.
Okay.
All right, so, so what we're gonna do now is when they're all wired together, we're gonna test the voltage of them.
Okay.
So this is still the most positive, and this is the most negative. So we're gonna clip the black onto the most negative, and then onto the most positive.
Touching.
Those are not touching. Are they touching?
They're close.
They're very close. Let's not do that.
So we get
Oh, that's even higher than the
maxed out, so what I need to do is turn up the setting, and we get about 4 volts.
4 volts. That's
That's
pretty good.
That's more than 2 batteries.
That's more than 2
Alright,
batteries.
so let's
This is about more than that. It's about 2.5 AA batteries.
and this is just for fun. This is just a light switch.
Yeah, we're going to wire the light switch in there just to make it a little bit more fun, because what we're going to do next is demonstrate that this comparatively low amount of voltage can still light up an LED.
Right.
So that's kind of the part 2. Part 1 was the making the battery. Part 2 is different sources of light. So if you look up at our wonderful visual aid, you'll see the 3 most common sources of light in any home: LEDs, incandescents, and compact fluorescent, the tongue twister. And it's also the twisty type battery, the new one that's getting very popular. Incandescent are the old type, the Thomas Edison type, and LEDs are the cool way of the future thing. And what we're going to see, just speaking generally, and you'll see in a second, is that LEDs have the best efficiency. Incandescents are pretty bad, and compact fluorescents are also pretty good, but they're not nearly as good as LEDs.
They don't last as long.
They don't last as long, and they're not as good for your eyes either.
So what Paul means by efficiency is, so even if you have the same amount of energy going through something, for example, an incandescent bulb, which is like a normal light bulb, will get hot because a lot of the energy goes to heat instead of to light. So if something's more efficient, a larger percentage of the energy is going to light, so you don't need as much to light up your house.
And what we'll see, because LEDs don't get so hot, they also last a very, very long time. LEDs can last for decades, whereas an incandescent bulb usually breaks after, a couple of years usually. Compact fluorescents also have a pretty long lifetime, but not nearly as long as LEDs.
Okay.
The cost, however, that's the problem. If you want the future sciencey type, LEDs are kind of expensive.
But since you save on your power bill, it can make up for it over time.
And you only have to buy them once every 20 years or so.
Something like that, yeah.
So, do we have the LED
What I
wire?
have is a battery and a light bulb, and right now the switch is off. Now if I turn it on, if you look directly at it, you can see.
Tell you what,
it's
let's
lit up.
get some
Yeah, it's
darkness
lit
in
up.
here really quick. So
If you look directly at it, you can see it too. See that?
you can see that dim green light? It's not very bright, but think that we just made that light up with
With the lemons.
With lemons.
That's kind of cool.
So, now...
Turn that off. So what do you think will happen if I connect an incandescent light? This is just like a small version of like what you would have in your house.
do you guys have an idea?
It'll light up. So like brighter, dimmer, not at all.
Really dim? Alright, let's try it.
Let's try it out.
I'll get the lights out. Do one of you kids want to flip the switch?
Sure.
Bam.
Not
Well,
this switch,
it's not lighting up at all actually. So it's the same amount of, it's roughly the same amount of voltage because it's the same battery.
Turn the lights
Yeah,
back
you can turn it back.
Right. So that's not lighting up at all, even though the LED does light up. So what we're seeing is that the LED requires fewer volts, so less voltage.
It takes less electricity to get to light up the same brightness.
Correct.
So have you heard of like climate change, global warming?
Yes, we have.
So that happens so a lot of electricity is generated like burning coal and it pollutes the environment. So what you want to do is try to use as little electricity as possible. So one way of doing it is
Yep,
using
just one of many ways to save money.
So actually, so if you were to buy an LED for your house, it wouldn't be like a giant version of this because that would look kind of stupid, and also because it doesn't really work. So
Right.
it wouldn't be bright enough. So what they do is they make a bulb with like a bunch of these inside it, and they're more expensive, but they last longer and you save on your electrical bill.
All right, so in conclusion, lemon battery, LEDs are better. Any questions? None at all? Oh, you explained it perfectly. All right, wonderful. Well, I hope you had fun.
Thank you.